So study guide for our complex numbers. We are looking at number 1 right here. So this says if the discriminant is negative, how many solutions do we have? So if b squared minus 4ac is equal to some negative number, all right, that means that we're taking, in the quadratic formula, we're taking the square root of a negative number, which means we have imaginary solutions right there. So this has no real solutions. So we say this has no real solutions. Okay. Number 2, if the discriminant is 0, how many solutions do we have? So if our discriminant is 0, if b squared minus 4ac equals 0, that means in the quadratic formula, you're taking the square root of 0, which is just 0. 0 is not positive, it's not negative. So we only have one solution here. Okay, that means that on my graph, I am only going to just touch the x-axis at one spot. If the discriminant is negative, my graph is never going to touch the x-axis. It may be above it, may be below it, all right, as a downward facing U, okay? Number 3, so this says simplify I to the 57th and I to the 58th. So I'm going to do this in 2 cases. This side's I to the 57th. This side will be I to the 58th. The question we need to ask ourselves is how many I squareds will go into this. So if I take 57 and I divide it by 2, so how many I squareds will go into that? Well, I know 25 I squareds will get me to 50, right? 26 I squareds will get me to 52, 27 I squareds. So what's an easy way to do that with? Well, an easy way would be to divide by 2. So if I take 57 and I divide it by 2, what do we get? Or 56 divided by 2. So there's 28. So we have 28 I squareds. Okay? And then one extra I. Because this would be like saying I to the 56 times I, right? So I have 28 of the I squareds. I don't like the way I wrote that. Sorry. So I have 28 I squareds in there. And we know that I squared is equal to negative 1. So I have to think about, all right, if I have an even number of I squareds, if you take I squared times I squared, that's an even number of I squareds because there's 2 of them, then I'm going to get positive 1 every time. So those 28 I squareds will give me positive 1, and then I'll have 1 I left on the end. So for I to the 57th, we're just going to have I as our answer. Okay, and then I to the 58. So think about how many I squares go into 58. If I do 58 divided by 2, that means we have 29 I squareds in that, in I to the 58. Okay, so if I have 29 I squareds, that means I'm multiplying negative 1 by itself 29 times. Okay, so that's an odd number of times that I'm multiplying by negative 1. And since that's an odd number of times I'm multiplying by negative 1, that means I'm going to get negative 1 out as my answer. So this is just negative 1. Okay, there's no extra i's on the end.
You say negative 1?
Negative 1. Yep. Sorry. That should be negative 1. Let me rewrite that. So this will be negative 1. Because an odd number of I squareds is going to equal negative 1. Okay? Number 4. So express this in a plus bi form. So all we're doing is combining our like terms. So I have 8 and I have 7. 8 plus 7 is 15. Okay, 6 plus negative 2i is 4i. So this is 15 plus 4i. That's it. That's all you have to do on number 4. Very simple. Okay, number 5. So express in a plus bi form. To do this one, I am going to use the box to perform this multiplication. So on one side we have 3 plus 5i, and on the other side we have 2 minus 7i. So let's think about what's going on. 2 times 3 is going to give me 6. All right, so we've got 6 in this first box, positive 6. 2 times positive 5i is going to give me a positive 10i. Okay, negative 7i times 3 is going to give me a negative 21i. And then negative 7i times positive 5i is going to give me a negative 35i squared. Okay, so we have all of this added together in our box. So we have 6 plus 10i minus 21i minus 35i squared. Okay, but there's some like terms that we can take care of. I have like terms with the i's in the middle. So positive 10i minus 21i is a negative 11i minus 35i squared. Now my I squared turns into a negative 1 because I squared is the same as negative 1. That's one of our rules that we have. So I have negative 35 times negative 1 right here, which turns into a positive 35. So we have 6 minus 11i plus 35. And now I have another set of like terms, the positive 35 and the positive 6. You add those two together and we get 41 minus 11i. And that is the simplified version of that one for number 5. Okay, on number 6, doing the same thing, but now we have x's in there. So we have x plus 3i and x minus 3i. Filling out our chart the same way, just now we don't have numbers in those first two spots. It is an x. So x times x is x squared. X times 3i is 3xi. Positive 3xi. Okay. Negative I times x is a negative 3xi. And then negative 3i times positive 3i is a negative 9i squared. Okay, so I'm going to do a little bit of my simplification, same process as earlier. All right, I'm going to go ahead and simplify this 9i squared. Negative 9 times negative 1 is going to give me a positive 9 in this box. So this is like saying positive 9. And I noticed that negative 3xi and positive 3xi are going to cancel each other out. And that's going to give me 0. So the only thing I'm left with is x squared plus 9. And why does this make sense? Right? That's my answer. Well, you know, we could take this a step further and really kind of expand upon that. If I were to try to solve that, and I were to move the 9 to the other side of the equal sign, we would have x squared equals negative 9. And then if you were to take the square root of both sides to solve for x, we would get that our x's are equal to positive and negative 3i. Okay, and as you see here, if we were to set this equal to 0, right, a negative 3i plus 3i is equal to 0, and a positive 3i minus 3i is also equal to 0. So that's why these two are our solutions for this one. Okay? Relating this back to what we were talking about with the graph and with the discriminant. If we remember way back, plus 9 is going to shift my parabola up 9 units. So my u is going to be up 9 right here. And one thing I notice is it doesn't touch the x-axis, does it? Okay, my graph is above the x-axis, which means there are no real solutions. This would give us a negative number for the discriminant right here, which means we have those complex or imaginary solutions, and my graph never touches the x-axis. Okay? A couple more. 7. Find all the real and complex solutions to the equation using the quadratic formula for this. First thing we have to do is subtract x from both sides to get this equal to 0. When we do that, we get this equation here. 3x squared minus x minus 4 equals 0. So we're having to plug into the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. So when I plug these things in, a is 3, b is negative 1, c is negative 4. Okay? What numbers do we get here? I'm going to do this the long way. You guys probably are typing this into your calculator and just getting one answer each time. But I'm going to work this out by hand as we're going through this. So we've got negative b, so negative 1 plus or minus the square root of b squared, so negative 1 squared minus 4 times a is 3 times c is negative 4 all over 2 times a, 2 times 3. Okay, so if we look at this discriminant under the square root sign, we got negative 1 squared. Well, that's positive 1. Negative 4 times 3. Let's see, negative 4 times 3 times negative 4 is a positive 48. So we get 1 plus 48. So this is going to be 1 plus or minus the square root of 49 all over 6, because 2 times 3 is 6. All right, and we can work this out pretty easily. The square root of 49 is 7. So you get 1 plus 7 over 6, and you get 1 minus 7 over 6. So my two answers here, one of them is 8 over 6, and one of them is negative 6 over 6. So my solution should be x equals, if I divide both of those by 2, that's 4 over 3. You might have got 1.33 repeating. All right, for that one. And then this one, negative 6 divided by 6 is negative 1. Okay, so that should have been my two solutions for number 7. Okay, that's using the quadratic formula, and that's actually working it out by hand right there. Okay, number 8. Use a discriminant to determine the number of real solutions, keyword real solutions, to the following equation. So the discriminant is just b squared minus 4ac, that part of the quadratic formula. So here I need to label a, b, and c. A is 2, b is 8, c is 1. And we're just plugging this into our formula here. We got 8 squared minus 4 times 2 times 1. Well, 8 squared, 64, minus 8. 64 minus 8. Really don't care what the number is. It's 56. The biggest thing here is that this is a positive number. And if we have a positive number for the discriminant, we are going to get two real solutions. All right, that is number 8. Last two right here, 9 and 10. So if the graph touches the x-axis at exactly one place, how many solutions do we get? I've already explained this in number 1. So if we touch the x-axis in exactly one place, we get one solution. Okay, and if we don't touch the x-axis, we get no real solutions. So number 9 is really what we've already talked about in number 1 and number 2. So if we touch the graph at one place, there is one solution. And if the graph does not touch the x-axis, then there are no real solutions. Okay, last one, number 10. All right, as we're looking at number 10, what are the x-intercepts of x squared plus 3x plus 7? When I'm asking for the x-intercepts, I'm asking for, can we solve for x? So we either have to factor, we have to complete the square, we have to use the quadratic formula. Whatever method we choose to use is going to help us solve for x. The problem with trying to factor this is if I were to try to do this and get the factors of 7, the only things are 1 and 7. The problem is that would give me an 8x in the middle. And we need 3x to be in the middle because 7 plus 1 is 8. So I can't factor this one. Okay, I have to use the quadratic formula for this problem. So A is 1, B is 3, C is 7. I'm going to have to plug this in to my calculator into the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, 2 times 1. So again, we're working this part out. If I work out the discriminant part, b squared minus 4 times a times c, that's going to give me 9 minus 28. Which is a negative 19. So we have negative 3 plus or minus the square root of negative 19. Okay, so negative 3 plus or minus the square root of negative 19 all over 2. All right, so the x-intercepts are going to be the solutions for this. We can actually get the complex solution with our imaginary number from negative 19. So we have to remember that the square root of negative 1 is I. Okay, so this negative 19 right here can be rewritten as the square root of negative 1 times the positive root of 19. The square root of that negative 1 is I. And we're just going to leave the square root of 19 as the square root of 19. So all of this up here becomes this. So our final solution here for what the x-intercepts are is negative 3 plus or minus I root 19 all over 2. So those would be the x-intercepts for